This troubleshooting video is intended to familiarize you with the key components of the WICK 375 engine, followed by the basic essentials of properly priming and starting the pump. It will then focus on some potential problems regarding starting the pump or its operation in the field, as well as detailed steps on how to overcome them. The video does not cover the pump end or its setup. For the proper operation and setup of all our pumps, go to the Support tab on our website homepage, then click Videos and find the WICK 375. The following are some of the key components and their respective locations that we need to be familiar with for this pump. Ignition switch, throttle, choke, air filter, fuel line and fuel line filter, cutout switch, spark plug, carburetor adjustment screws. If you're having trouble starting the pump, let's start with the basic checks. Verify that the on-off switch is in the on position. Throttle to the start position. Open the air vent on the fuel tank. This is a critical but an often forgotten step. Before connecting the fuel line to the pump, it's important to first prime the tank fuel line in order to purge any air in the priming bulb and fuel line. Here we are using a male Chrysler fitting to facilitate fuel flow back into the fuel tank as we depress the priming bulb. The priming bulb must be held in the upright position as demonstrated to purge any air. Now we connect the fuel line to the pump and continue to prime the pump's fuel line until we see fuel flowing through the pump's fuel filter and up to the carburetor. At this point, do not continue priming, otherwise flooding can occur. The fuel priming is now complete. For a cold engine, place the choke to the closed or start position. Opening the choke after the first ignition is a critical step in order to prevent flooding. Listen carefully for the first ignition as we hear here. It might sound as subtle as this. With the choke open in the run position, pull the starter rewind until the engine starts. This should not require more than 2 or 3 pulls. Allow a brief warm-up period and adjust the throttle as required. Common causes of flooding are choking a hot engine, failure to open the choke after initial ignition, or choking a warm engine, assuming that it required choking. All of these will allow too much fuel to flow into the cylinder, causing flooding. We will now demonstrate what to do if the engine is flooded. Assuming the engine is not severely flooded, with the ignition still in the on position, open the choke, position the throttle to 3/4 full, and give several pulls on the starter rewind. This will purge any fuel. It should start after 3 or 4 pulls. If the engine does not start, it could be severely flooded. In other words, after multiple attempts to start while the other checks all appear to be okay, then we recommend simply changing the spark plug, therefore knowing we are now attempting to start with a dry contact. This usually works. The air filter should be checked periodically and replaced if necessary. A dirty filter can impede the engine from starting or cause it to stop after a short running time. Only loosen the wing nut as demonstrated so as not to drop the nut and washers. Remove the filter and replace if necessary. A good habit is to always observe the flow of fuel through the fuel filter during priming and operation. Replace if it appears dirty or if you observe restricted fuel flow. If all the checks appear good and the engine is getting fuel and does not appear to have been flooded, then we should focus on the ignition side by removing and inspecting the spark plug. If no visible defects, then we can validate for a good spark as demonstrated here. Caution must be taken to ground the spark plug away from the opening since there may be gas fumes. Visually inspect the spark plug for signs of damage. Any damage would be an obvious defect for not getting a spark. Visually inspect this connection. Gently pull while twisting this connection to confirm proper connection. Again, this should be an obvious defect when examining the magneto lead wire. In the case of a suspected magneto problem, contact your nearest authorized dealer. The cutout switch protects the engine by shutting it down if the engine over-revs, for instance, in the case of loss of water prime. This is a rare occurrence, but should be ruled out if the engine is getting air, fuel, good spark, and all other checks are good. To validate, remove the cutout switch connection as demonstrated and repeat the starting procedure. Be advised that disconnecting the cutout switch will disable the overspeed protection, and the engine will no longer be protected against loss of prime. This procedure should only serve as a diagnostic step. Therefore, we do not recommend operating the pump with the cutout switch disconnected. Another possible cause of the engine stalling under load could be a dirty fuel line filter or a dirty carburetor. As previously mentioned, if this filter appears to be dirty, or we can observe fuel struggling to get through, then we should suspect a dirty fuel filter and replace. If we suspect a dirty carburetor, this can also be field repaired depending on your environment, or if not convenient, then the pump should be returned to your maintenance shop for attention. Carburetor adjustments could be another possible cause of the engine stalling under load. It is important to read the carburetor section of the operating manual since there are several factors that require fuel mix adjustments, altitude especially. A warning: improper adjustment of the carburetor screws could lead to severe and permanent engine damage. If the engine is overheating, then it is likely due to the carburetor fuel mix. Refer to the operating manual carburetor adjustments. A dirty spark arrestor could also cause the engine to stall under load. The spark arrestor has a screen to prevent sparks from escaping the muffler and can become blocked. It should be inspected periodically, and especially if the engine is struggling to keep running. Remove the spark arrestor, examine, and clean with a sturdy brush as demonstrated. Use a high-quality 87 octane or higher gas and 2-stroke oil, meeting class API-TC JASO-FD, and mix fuel to oil at a 24:1 ratio. For any questions or further assistance, contact your Mercedes Textiles authorized dealer.